So, I mean, it's provable. Did you see, you know, I'll just go back to this in the first paragraph, that you can see a star that's hiding behind the sun because it kind of goes out and around the sun. And its last known trajectory is where you see it come from. All right. Then another kind of talking about the fabric of space and time, and objects make dents in space and time. And then that objects, and that's what we call, actually that dent is what we call the influence of gravity. Okay, actually kind of a little bit of wobble that Mercury does as it orbits the sun is another indication of kind of the little divot that the sun is making in the fabric of space and time. Okay. So, white dwarf or neutron star. So that would be this object or this object. Okay. So what they have in common is very dense. Okay. And this is very, very dense. Okay. And that's even denser. So the deal is if you had a light that was in the vicinity of the, this light's going to get even closer. Okay. But say this light is potentially influenced by the gravity of the white dwarf or neutron star. There's something called gravitational redshift. And the closer this light gets, okay, basically that light is shining in all directions. It doesn't know. It's in on a battery. A battery is operating it, right? The closer it gets to that dense object, whether it's a white dwarf or a neutron star, the gravity of that object kind of creates a well. I've heard it kind of called a well before. And so the light coming up into you has to lose some of its energy to do that. It's called gravitational redshift. So actually, you know, we've talked about Roy G. Biv. You know, this is going back a while. But we said with regard to the colors, you know, this is the lowest energy, and this is the highest energy. Okay, so what gravitational redshift does is shift it. It uses energy, and it makes it a longer wavelength, basically. That's provable, too. So I have two slides that kind of go together, and actually they kind of review the two things that we talked about, the gravitational redshift and the time dilation. Okay, so I think we're okay with that. This is one of my favorite little videos. Thanks. Okay. So I think we'll go just 7 more minutes and finish this up. What's that?
Is it a guy?
It is a guy.
I didn't know it wasn't. I was like, what in the world?
It is.
It's really long.
So we'll let Neil describe this.